So let's get started with carbon family. I repeat one last time. I hope the board is visible to all of you. Now, carbon family, which is going to contain carbon, silicon, germanium, tin, lead. Now, along with carbon, silicon, germanium, tin, lead, which are the popularly known members of carbon family, there's another name which you'll want to remember, which is again named in NCERT as well, with atomic number 114. It's called flerovium. So I hope the board is visible to all of you. You know, there's something which is mentioned in NCERT as well. So I want you to know the name of this molecule. Naturally synthetically prepared, not natural, and it's radioactive. But along with carbon, silicon, germanium, till lead, there are various mnemonics to remember it. You know, one mnemonic I tell you in class, in periodic table class 11 is कहे सीता जी सुनो प्रभु. बहुत तरह से कार्बन सिलिकॉन जर्मेनियम टिन लेड याद रख सकते हो. Along with that, flerovium is a name you'll want to remember. Carbon is the 17th most abundant element by mass in Earth's crust. Obviously, a non-metal, exists in the very popular amorphous form of coal and the two popular crystalline forms of graphite and diamond. In atmosphere, carbon dioxide is 0.03%. The two natural stable isotopes of carbon are with mass number 12 and 13. C14 is a very popular radioactive isotope, you know, with half-life of 5,500 years plus. And, you know, that is the stuff we use for the very popular carbon dating. Moving on, silicon is the second most abundant element. Obviously, after oxygen, I told you last day as well, oxygen, then silicon, and then aluminium. These are the three most abundant elements obtained abundant in the planet as silica, silicates. Silica, silicates, silicones are again going to be compounds of peculiar interest, both academically and from exam point of view. I take it up in details maybe in the next class when I see you. Germanium is present in traces. Tin, the principal ore of tin is cassiterite SnO2. I think you know it's also called tin stone. For lead, the sulfide ore galena PbS is the most popular ore. Electronic configuration is NS2np2, naturally group 14 or group 4a of the past. 4 valence electron, carbon, silicon, germanium, tin, lead. When it comes to periodic properties, atomic radii, I find no anomaly, carbon, silicon, germanium, tin, lead, down the group size increases. In ionization energy, you know, there is a exchange between lead and tin. Down the group IE is supposed to decrease, but this is again a very, very prominent and a very, very common anomaly, which, you know, has come in different exams in the past. Naturally, before lead, you'll have 4F filling here. Now, F has very, very poor skinning effect. F has very, very poor skinning effect. And between tin and lead, you know, you get, you know, the Z increases by 32. So a lot of positive charge increasing in the nuclear becoming much more powerful, and very poor screening by the F electrons. Naturally, the valence electrons of lead will be much more tightly bonded than expected. And, you know, the reason behind this being reversed, there's, you know, poor shielding effect of D and F orbitals, particularly F orbitals, electrons to be very precise. Melting boiling point. Carbon, silicon, germanium, lead, tin. Again, यहाँ पर lead और tin के बीच में वो order reverse है. Boiling point, silicon more than germanium, more than tin, more than lead. Again, these are facts you'll want to remember. Down the group, melting point, boiling point decreases. For melting point, lead and tin have a particular anomaly. Any day, down the group, metallic character will increase. Carbon is a typical non-metal. So is silicon. Also, silicon dioxide can have a little bit of acidic behavior. We'll see that. Germanium is metalloid. Tin, lead are metals with low melting point. In general, for group 14, the melting point, boiling point is more than that of group 13. That's again understandable because they have one more valence electron. Carbon exhibits many allotropic forms, both crystalline as well as amorphous. The two very popular crystalline forms are diamond and graphite. Now, fullerenes discovered by these three scientists, for which they got a Nobel Prize in 1996, is again noted and copied from NCERT. Fullerene are compounds of some unique interest and application. We'll talk about it. Or also supposed to be one very pure form of carbon in nature. Diamond and graphite are allotropes which are aged old. Diamond is crystalline lattice, sp3 hybridized, 4 carbon atoms, tetrahedral manner, no free electrons. Now, bond length and all is something which you'll not want to mug up, but at the same time, a three-dimensional extended covalent networking, hardest substance on Earth, high density, high melting point. Things I guess all know. Used as an abrasive for sharpening hard tools, cutting glass, making dyes, tungsten filaments for light bulbs, non-conductor of electricity due to absence of free electrons. These are things which we know. We have been comparing properties of graphite and diamond, both physical and otherwise in the past. Chemically absolutely inert and non-conductor, sp3 hybridized. With graphite, a layered structure, sp2 hybridization, planar hexagonal ring, sp2 hybridized, and it's slippery because it has a layered structure. Van der Waals force, the distance between two layers is much more than the interatomic distance. So, there are pi bonds which are delocalized over the whole entire, region, and these mobile electrons would make graphite a good conductor of electricity.
Yes.
Soft and slippery, used as a dry lubricant. Now, these are things which you don't completely mug up, but at least, on a given day in a given exam, if you come across a question, it is about graphite, despite being extremely inert, if treated with nitric acid, sulfuric acid at high temperature, what is the name of the acid? So these are things which you don't mug up, but just before the exam, if you have read about it, seen it a couple of times, out of the 4 options, you'll be able to identify acid, strong acid, graphitic acid, alkaline KMNO4, mellitic acid, which is another name for benzene hexacarboxylic acid. Graphite is thermodynamically more stable than diamond. You know this from the days of thermochemistry. In thermochemistry, I did tell you that the most stable form of carbon is graphite. This is the one for which the delta H formation is taken as 0. So every time you take the heat of formation of carbon, you take the graphite form, which is supposed to be thermodynamically more stable. Now, this at very high temperature under a lot of pressure, is converted to diamond. Again, these are facts which you know. Fullerene, I know there are informations which are there from NCERT and otherwise. So fullerenes are made by heating graphite in an electric arc in presence of inert gas such as helium or argon due to material formed by condensation of vaporized Cn, where N is supposed the number of carbon atoms in a particular fullerene. C60, C70 are the ones which are most prominent, but they can have even up to 350 carbon or more in a particular ring-like structure. In all such compounds, which are called fullerene, they're going to be 5-membered and 6-membered rings, all containing carbon atom. Well, these are small little things. 5-membered ring and the count is 12. 6-membered ring and the count is n by 2 minus 10, where n is supposed the total number of carbon atoms in one particular fullerene. This is the only pure form of carbon because they have smooth structure without dangling bonds, cage-like molecules, C60 economic Buckminster fullerene. It 20-membered rings and 12 5-membered rings. So 12 5-membered rings is a constant number. This is a constant number, and this was n by 2 minus 10. So when you write n by 2 minus 10 for C60, 60 by 2 minus 10, 60 by 2 minus 10 is how you obtain 20 six-membered rings. A six-membered ring will fuse with six or five-membered ring, but a five-membered ring can only fuse with six-membered ring. So these are things again which have, particularly copy-pasted from NCERT, and you never know. One way or the other, you have to remember if it's a compound containing six-membered and five-membered rings which are fused with each other, the rule of the game is six-membered can fuse with both five and six-membered ring, but a five-member can fuse with only a six-membered ring. Or carbon sp2 hybrid, they form three sigma bonds with other carbon atoms, remaining electron is delocalized, giving aromatic character to the molecule. So these are again facts, which you'll want to remember. Ball-shaped molecule has 60 vertices. Each one is occupied by carbon atoms. Also contains both single and double bonds. It's not like, I repeat, you have to mug up the bond length, but I did it when I had a lot of time, but it's not like I am proposing that you should mug up these values, but it has single and double bond different, and they're also called buckyballs, are pieces of information you'll want to have. Graphite is thermodynamically more stable. I did tell you the heat of formation, this heat of formation of graphite is taken as 0. The corresponding values for diamond and fullerene are also written here. Yet again, you don't mug up these values, but this is 1.90 is something which stays with you in problem solving in thermochemistry. Now, the amorphous form. Carbon black obtained by burning hydrocarbon like benzene, turpentine, naphthalene in limited supply of air. Another name for carbon black is lamp black. Coke and charcoal are the ones which are going to be obtained from coal and wood. High temperature and absence of air. Destructive distillation of things which you would have learned at times. Uses of carbon, graphite fibers and plastic materials forming high strength, lightweight composites to form tennis rackets, fishing rods, aircraft. I think I've copied this from NCERT only. Crucibles made of graphite, activated charcoal being very porous, used in absorbing poisonous gases. It's going to play a role in the discovery and the separation of inert gases as well. Water filters, air conditioners, carbon black used in black gluing, paint, automobile tires. Coke is a popular reducing agent, also a fuel. Diamond is precious, used in jewelry, goes without saying. Value of 1 carat is 200 milligrams. Again, if it's something there as a piece of information in NCERT, you'll want to remember it. Allotropes of tin. From carbon, when you move to tin, there are 3 allotropes. White tin, grey tin, and there is something called rhombic tin. White tin is the most stable, maximum density and used in containers of oil. तो tin के नाम से ना सबसे पहले दिमाग में naturally जो आता है वो tin का डब्बा ही आता है. So all the tin which you see around is white tin, which is more stable, and at low temperature white tin becomes grey tin. When heated at a high temperature, it becomes rhombic tin. Now white tin becoming grey tin at low temperature. And I remember there was a very interesting question in one of these exams. Maybe when JEE Mains was AEEE way back, they were talking about an incident, maybe a historical incident where, the army, Napoleon army, while conquering Alps in a particular war, the soldiers, were wearing uniform with tin buttons. Now, white tin is supposed to be, stable, and grey tin, I reckon, is powdery brittle. See, it's given. So white tin at low temperature becoming grey tin, which is powdery brittle. I don't know whether it's a fact or a tale, but I found it as a real question in a real exam, that the soldiers in the Napoleon army, they had a uniform malfunction because the tin buttons converted to the powdery form. Folding of tin sheets produces a sound which is called tin cry, and the conversion of white tin to grey tin is called tin pest, tin disease, tin plague, are again terms you need to get acquainted. Catenation. From the time you have been knowing carbon as the backbone of all organic compounds, catenation is the property of forming long chains, rings, and all. So what gives carbon this unique property of forming long chains, rings, is the fact that the carbon-carbon bond energy is 348 kilojoules per mole, which is very high. Silicon silicates are also going to be some prominent, chain-like structures, ring-like structures, but down the group, the value is certainly decreasing. What also makes, carbon as the backbone of all organic compounds containing various functional substances. If you look at this particular information, that the bond energy of carbon, 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 oxygen, carbon, chlorine is almost equal. It helps in converting one form of carbon bonds to another form of carbon bonds, and that is the uniqueness which carbon has. Naturally, it's the element which shows maximum catenation property. Now, this is very, very important. This is extremely important. All of inert pair effect which I teach you, generally after lanthanide contraction and all, because in inert pair effect, it will be about the lower oxidation state. See, this is the natural oxidation state. The higher oxidation state is always the natural oxidation state. So with the configuration NF2NP4, it's involving all the 4 electrons, plus 4 will be the normal oxidation state. And plus 2 would mean, I'm sorry, NF2NP2, 4 valence electrons. And with plus 2, it will mean that only p electrons are involved, and plus 2 would mean that NS2 has gone inert, and thereby the name inert pair, NS2 not participating, is about it exhibiting a lower oxidation state by 2 units. The normal oxidation state is plus 4 here. So for all the lower members of P block, when I talk about inert pair, I want you to literally know what inert pair. It's about the outermost pair of s electrons which become inert. And this inert pair is most pronounced in particularly carbon family, where you'll see plus 2 and plus 4 as two popular oxidation states. Now, moving down, inert pair effect becomes more prominent. IPE, inert pair effect, increases down the graph. And if it increases down the graph and is the most prominent for the lowest member, as it increases down the graph, नीचे वाला स्टेट नीचे स्टेबल होता है. ये एक बहुत सिंपल तरीका है इसको याद करने का. नीचे जाने से नीचे वाला स्टेट स्टेबल होता है, ऊपर से ऊपर वाला स्टेट स्टेबल होता है. जितना नीचे जाएगा उतना नीचे वाला स्टेट स्टेबल होगा. So by नीचे वाला state and ऊपर वाला state, I mean the lower and the higher oxidation number. One simple way to remember this is when you move down, the lower oxidation state becomes more stable. But eventually, because the higher oxidation state is still the natural oxidation state, Sn plus 2 is explained using IPE. But Sn plus 4 being more prominent, Sn plus 4 being more stable, Sn plus 2, you would have seen this acting as a reducing agent very, very often. Because tannic is more stable, Stannous is going to act as a reducing agent. But for the lowest member, which again is about f electrons, very poor shielding, and the size being extremely small, energy synergy, those factors pitching in, NS2 will become very tightly bonded. To the extent IPE would become the major oxidation state for plumbus and plumbex. Plumbus is more stable, so plumbus is more stable, and plumbus does not act as a reducing agent. On the contrary, plumbex starts acting as an oxidizing agent. Stannous acting as a reducing agent is about its willing to get oxidized, and plumbex acting as an oxidizing agent is about its willingness to become plumbus, the lower oxidation state. At the end of the day, as I told you, you move down, the lower oxidation state becomes prominent. They all form oxides when heated with oxygen. The two common oxides are monoxides and dioxides. FiO exists only at very high temperature. The higher oxidation state is always going to be more acidic in case of non-metallic oxides. Non-metallic oxides, the higher oxidation state, more charge assigns more electronegativity. Talking about the dioxides, carbon dioxide, silicon dioxide, germanium dioxide are acidic in nature. Stannous, plumbus, both oxides and monoxides are amphoteric. Stannous, plumbus, they are amphoteric in nature. Germanium oxide, monoxide is acidic. Carbon monoxide is a very popular neutral oxide. Carbon monoxide, N2O or NO, ये तीन तुमको neutral में मिलेगा. Obviously, water can also be taken as a neutral. It's not a gas by the way. When it comes to forming halides, two types of halides are possible: dihalides and tetrahalides. Except carbon, all members react directly with halogen. NH4 is the most covalent, except SnH4, PbF4. So naturally, moving down, you'll find the most metallic and chlorine being the most electronegative. These are going to be the halides which at least have some ionic nature. Tetrahedral nature, sp3 character. PbI4 does not exist. PbI bond form does not release enough energy to unpaired, or ACD iodide being a strong reducing agent, plumbus को plumbus कर देता है. I minus का presence में ना, Pb plus 4 will become Pb plus 2. PB plus 2 is even more stable. Common and effect and all. Inert pair effect and all. Inert pair effect and all. So these are facts which you need to know. NCERT से copy भी है काफी सारा. Heavy members, germanium tolate, they'll form MX2. Stability of dihalides increases down the graph. Yet again, something which is explaining plumbus is more stable than plumbate. Germanium with a higher oxidation state is more stable than. So नीचे जाने से नीचे वाला स्टेट स्टेबल होता है, सबसे नीचे वाला का सबसे नीचे वाला स्टेट स्टेबल होता है. Between fluoride, bromide, hydride, this will be the order of stability going by the bond energy values. PbBr4, PbI4 does not exist because of oxidizing nature of P plus 4. I told you reducing nature of Br minus 5 minus. Br minus 5 minus bromide iodide will reduce plumbate to plumber. Except CH4, other tetrafluorides are easily hydrolyzed by water because the central atom can accommodate the lone pair of oxygen. So there is a particular theory which says that suppose the silicon tetrachloride is hydrolyzed to the silicic acid. Now, presence of d orbitals would facilitate attack of this oxygen, and the lone pair being accommodated in the empty d orbitals would aid in hydrolysis. Now, it's not possible for carbon, like any second period element, there is no D. So carbon halides, carbon tetrahalides are not hydrolyzed. The others are going to get hydrolyzed because of this popular theory that having d orbital would facilitate attack or accommodation of this lone pair by water, and one by one the 4 chlorine will be replaced by 4 OH. You should know silicic acid. SiF62 minus is known, SiCl62 minus not, because 6 large chlorine cannot be accommodated around Si plus 4. Absolutely important. सब NCERT का और common books का common information है. We move on to some important compounds of carbon and silicon. Now, the silicon wala part I'm going to do maybe next day. I'll talk about silicon dioxide stand and all silicates and silicones. I'm still, in the process of making those notes. I might end up doing it by tomorrow, or I want to share it at the first opportunity. Carbide and its salt like produces hydrocarbon and hydrolysis. Beryllium aluminum carbide with water will give you beryllium hydroxide, aluminum hydroxide. Because they give methane, they're called methanites. So, we have done this in alkanes, we have done this in hydrocarbons, class 11. Calcium carbide giving you acetylene, magnesium carbide giving you profine, arginine pieces which you would remember. Silicon carbide, boron carbide, a covalent, interstitial carbide. Transition metal के साथ में they form this kind of a compound. This compound at hard, high melting point, boiling point. Cementite in white cast iron is something I do tell you in extraction of iron, chemically inert. Hydride. Carbon form large number of hydrides. Alkane, alkene. Silicon hydrides are called silane. SiNH2n plus 2, monosilicane, silicon methane, disilicane, silicon ethane. When it comes to oxides and silicates, I'm going to take it up as I told you in more details. Silanes up to N is equal to 8 are known. Hydrides of germanium are called germanes, GH4, GH2H6, but these are rare in number. Naturally, the most common hydrides are of carbon only, forming the entire family and the world of hydrocarbons. Then silanes, then germane. SNH4, PbH4 obviously have very little stability and less relevance. Silanes are more reactive than methane due to low bond energy, more polar bond, d orbitals. You just have to know this for one. Stannane, distannane, plumbane. I told you in JEE Advanced, they have this habit of asking questions which are a little information based at times. And this is, across the barrier a bit. Along with NCERT, I've given some information, which would be required in, those information-based questions. So you all know about alkene, a little bit about silane, germane. इनका दो होता है, stannane, diastane, plumbane, blood का एक ही होता है. Again, piece of information. Carbon monoxide, carbon dioxide, carbon suboxide. Carbon monoxide formed by incomplete oxidation of carbon. On small scale, it's produced by formic acid, dehydration. commercial scale, water gas, synthetic gas is a mixture of carbon monoxide and water, hydrogen. So carbon coke generally, when passed over hot steam, you get water gas, synthetic gas. Using air, a mixture of carbon monoxide and nitrogen is called producer gas. They're popular fuels, they're important industrial fuels. They are important industrial fuels. K4FeCN6, this is an important reaction. This is an important reaction, because K4FeCN6 is also in our scheme of things. K4FeCN6 is sulfuric acid H2O. When I'm discussing the properties of K4FeCN6, I am obviously going to talk about this reaction. Sulfuric acid, potassium ferrocyanide gives the ammonium sulfate, carbon monoxide. No, remember this. Potassium sulfate, ferrous sulfate, toxic. Expected here, they're going to form metallic sulfate. But ये ammonium sulfate बनाता है, carbon monoxide बनाता है, is an important information. Colorless, odorless, neutral, almost insoluble, poisonous nature because it can form carboxyhemoglobin. Hypoglobin loses its oxygen carrying capacity, causing death. So you just need to read it. I don't want to write it down, but these are things which you know already. Burns with a blue flame, powerful reducing agent, reduces all metallic oxide, is the main reducing agent in extraction of iron. Blast furnace में, if they ask you which is the most common reducing agent, the principal reducing agent of iron in blast furnace is carbon monoxide only. From carbonate with D block elements, with lone pair present on carbon of carbon monoxide acting as a donor, kind of a ligand, burns with a blue flame absorbed by solution of cuprous chloride in ammonia or HCl. Due to complex formation, forms phosgene with chlorine, reduces I2O5, iodine used for estimation of carbon monoxide, are all information which you'll want to just know. And write in a piece of paper if you find a question based on the same. Maybe the next day I'm going to solve questions based on carbon and boron family. Maybe a couple of more classes and then we'll be seeing JEE advanced questions as well. Carbon dioxide, complete combustion of carbon and other fossil fuels, organic compounds, section of diluted film, calcium carbonate, bicarbonate, bicarbonate, they'll all give you carbon dioxide with any mineral acid, colorless, odorless gas, soluble in water, forming carbonic acid, carbonate, they form a buffer, maintaining blood pH, human blood pH, 7.26 to 7.42 does not need to be literally exactly clinically remembered, but it's more than 7. Non-poisonous but non-supporter of combustion are like, but high temperature per some metals will burn, like magnesium, potassium, they'll burn, forming white powder and all. Acidic in nature, reacts with metallic oxides, forming carbonates, bicarbonates. Is there an air reagent of the process called photosynthesis, which is running life on this planet? This is the eventual ultimate source of food and energy. To all living beings, this is like a reagent in the process. Plants make food for themselves and, solid carbon dioxide. You know about greenhouse effect. So know a little bit about greenhouse effect. More carbon dioxide and, is responsible for global warming. It doesn't let the radiation go back to the space. It's absorbing heat, raising temperature and causing global warming. Solid carbon dioxide, dry ice. You would have known this in the past. It is used as a refrigerant. The process is extremely endothermic, used in forming ice creams, maintaining very low temperatures. It is sp hybridized, non-polar, linear are things which you all know. Carbon suboxide, C3O2, linear. How do you prepare carbon suboxide? When I talk about the heating effect of dicarboxylic acid, I do tell you about this particular reaction with P4O10. Naturally, if it's heated of its own, a gem dicarboxylic acid, simple heating, and it will lose carbon dioxide to form CH3COH. But when it's heated with a dehydrating agent, I can. This is certainly in my video on organic chemistry, heating of dicarboxylic acid. It's a gem dicarboxylic acid. So one piece of information you have is, it will lose carbon dioxide on heating, plain heating, but with a dehydrating agent, this is important. It forms C3O2. Colorless gas reduces polymerizes. तो ये सब देख लेना 2000 डिग्री पे कार्बन डाइऑक्साइड बन जाता है. Carbonate does not exist. A carbonate exists. CO4 4 minus exist नहीं करता है. FiO4 4 minus exist करता है. सारा silicate का story I'm going to share with you in the next class. Carbonate is small. Carbonate flat planar. Carbonate stable, melt without decomposing. Now this is a group 1 property. Sodium carbonate, potassium carbonate. They'll melt, but they'll not dissociate. Lithium has a problem that lithium, has a diagonal relationship with magnesium. Now, magnesium, calcium, and all, magnesium being group 3, will be a typical group 2 element, and magnesium carbonate and calcium carbonate and lithium carbonate, they'll dissociate to give you carbon dioxide and lithium oxide and magnesium oxide. So they're like typical carbonates. Group 1 carbonates are particularly different, they don't dissociate. Group 2 carbonates dissociate, as I told you, stability will increase down the group. The stability will increase down the group because down the group they'll become more metallic. More metallic, more ionic, would mean more thermal stability on all their compounds. Ammonium carbonate and group 1 carbonates are soluble in water, except again lithium carbonate, which will behave like group 2 carbonates, which are like precipitate. Only solid bicarbonates are group 1 and ammonium. All bicarbonates are soluble and decompose on heating. So yet again, I think, it does not take a big call for you to have a printout of the notes which I'm sending across, attend a class of this kind, or in the worst case, watch the video to be ready for, problem solving. Really grateful for those who are attending the class online, and certainly those attending the class online will have this liberty of asking for help just by the time this class gets over, and I'll provide that help again at the first opportunity. Friends, I remember you want surface chemistry. It's something which I'm going to say right away. Give me a little while. I'll just have to search for it. Hydrogen family, hydrogen and its compounds. I'll have to search for it.
Yes.
But surface chemistry.
So जो doubt भेजा था वो भी.
हाँ वो मैं देख लेता हूँ. I just have my lunch right now, and
Yes.
as I told you at the first opportunity, I'll discuss your. I'll answer your doubt. And surface chemistry discuss. Surface chemistry is again something which was not JEE means and the school curriculum, board curriculum, but advanced math. Surface chemistry based. Just for the time being, stay happy, stay healthy. मिलते हैं बच्चे लोग. Take care.
Bye, sir.
God bless you.